Welcome to Valence Electrons and Electron Dot Diagram notes. You're going to copy this file in Notability, and I would go ahead and add your name right in here so I know whose notes they are if I happen to download them and I lose them out of Canvas. It doesn't really tell me your name if it's a file standing alone. Okay, so you've added your names, and we're going to begin with this part of our text. It talks about valence electrons, and we discussed that you look at the group number to help you decide how many valence electrons that each element has. We know hydrogen over there is in group 1, so because hydrogen is found in group 1, it has 1 valence electrons. So to show a picture of valence electrons, we use what they call an electron dot diagram. And it's simply this: you take the element symbol and you put the quantity of valence electrons by using a dot. So hydrogen looks just like that. And carbon is over there in group 14. Remember, we took the 10s, the 14, and we took the 10s place off of it. And so then it has 4 valence electrons, and you use the letter C for carbon, and you put the 4 dots surrounding it. The reason you do it this way, with the 4 dots showing here, 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 and here, because it kind of balances out the element and the atom. Oxygen right here, we know that is found in group 16 if we're looking at the periodic table. Well, in valence electrons terms, you are going to drop that teen off, so that means it has 6 valence electrons, and you start here in position 1 with the first dot, and then you kind of go around. If there isn't enough to go to double up, you just keep going around. So I would put 1 here, 1 there, 1 there, 1 there, and that gives me 4, and so I know I need more. So we pair it up after that. That's 5, and there is 6. If it were to be 8, we would go ahead and pair up at the next 2 places. So that right there is oxygen's electron dot diagram. Okay, and this one here for neon, it tells us that we should use dots to show the number of valence electrons here, and this pencil right next to the pencil, we find that neon is sitting in group 18. So if I know it's 18, we can drop that teen off, and we know we're going to put 8 dots around it. So 1, 2, 3, 4, and then we have more, so we have to pair up on each of those sides. 5, 6, 7, and 8. So there you have it with neon. Moving on to the next page, this is a picture showing the electron dot diagrams in a pattern on the periodic table. So we're going to zoom in here. This valence electron group, the alkali metals, it also includes hydrogen, even though they are very different. In this case, they act similarly. And we go by that group number. So if we have the group number 1, we're going to find that it is going to have 1 valence electrons. And we know group 2, we have 2. Group 14, we drop that teen off, and so we have 4. We drop the teen off of the 18, so we have 8. So the same pattern goes. The group 13 is going to have 3, the group 15 is going to have 5, the group 16 is going to have 6, the group 17 will have 7. You just drop that teen off. Now remember, I told you that these here are going to have different rules, so we're going to ignore them. Those are the transition elements, and you'll find out later on in chemistry how weird those guys actually are. So sliding over to the next page, we're going to end up using our periodic table over here as a reference. I'm going to make my marker a little bit smaller. It wants to know what electron dot diagram would look like for each of these elements. We have nitrogen, oxygen, and fluorine in that first level. So here's a pattern for you. Lithium, switching colors, lithium is going to be found right here in group 2, so it has 1 valence electron. If you look down beneath it, you see sodium. Sodium's right here in period 3 of group 1. So sodium, using a different color, you're going to find right here. So we can infer, because we know how patterns go, we can infer that that is going to give us the same 1 valence electron in sodium as it did in lithium, and you place it right in that same position that you see lithium. Okay, we have beryllium there. It's already done for you. Beryllium is located over here in group 2. You can't see it because I wrote through it. There we go. Get rid of those. Beryllium is sitting over there in group 2. And we see on the periodic table it's going to have 2 valence electrons, and they have 2 electrons, therefore its valence quantity. Magnesium, if you'll notice, is right below beryllium, so we're going to follow the same pattern. If it's in group 2, it's going to have 2 valence electrons. So I look here, I'm going to put mine 1 here and my 1 here, and that gives us magnesium. Boron is a group 13 valence electron, and it is found right here for boron, and it's going to be group 13, and it has 3 valence electrons. It's already done for you in that example. You'll find that aluminum is smack dab right beneath it, and any of these elements right here in the same group 3, they're going to have 3 valence electrons. So aluminum is going to look just like boron with 3. I don't know if you can see my 3 yellow dots, but there they are. I'll switch colors again, and we'll look at carbon. Carbon is found over here in group 14. Since carbon is right here in group 14, we know it has 4 valence electrons. So 4 valence electrons has 4 dots for carbon. Silicon is right beneath it, and it's in the same group. Anybody in this group is going to also see the number 4 valence electrons. And silicon, we're going to put those valence electrons on, 1, 2, 3, and 4. Nitrogen. Nitrogen, located over here. I'm going to switch colors. Nitrogen is located over here in group 15. Group 15 has 5 valence electrons, and if you'll notice, phosphorus is right beneath it, and phosphorus has 5 valence electrons. 5 valence electrons here, so we're going to put them on 2, 3, 4, and when you have another one, you're going to pair it right up, so you see it has 5 total valence electrons. Oxygen is our next example. Oxygen is going to be found in our group 6 right here, and it has 6 valence electrons. In our example beneath, it shows us that sulfur has 6 valence electrons as well. So we're going to go ahead and start with our 1, 2, 3, 4, and it has 2 more, so we're going to use them to pair up on the sides. Fluorine and chlorine are in the same group because they are halogens. We use them in our water supply. Right here in group 17, and we know because group 17, we drop that teen off and we get 7 valence electrons. You put 1 down on each side, and then you realize you need more space, so you need 3 more to fill in, so you pair them up, and you are finished with, oh, I forgot to put 6 here. And you're finished with your 7 valence electrons. And finally, we have our group 18 elements. Over here, we have neon and argon. Neon and argon. Those are our noble gases, and we know that they do not bond because they're too good. They don't like to hang out with other elements, just themselves. Royalties, so you may say, the noble gases. It has 8 valence electrons, so you put 4 on each side, or 1 on each side to make 4, and then you need 4 more, so then you go around and pair them up, and they have a total of 8 valence electrons. Now let's look at the next questions up here, number 2, right here. Fluorine and chlorine are in group what? Again, fluorine and chlorine are in group 17. So we're going to write that down. And then the fluorine atom has how many valence electrons? Because it's in group 17, we know. Oh, I didn't. Fluorine and chlorine right there. Group 17, that they have 7 valence electrons. Now we're going to go on to number 3 here. Predict. How many valence electrons does bromine, Br, have? So we come over to the periodic table. We're going to search and get rid of some of my writing on here. For my bromine, there it is. I see it right there in group 17. And we know if fluorine and chlorine also have 7, so each one of these that are a halogen, they're going to have the same 7 valence electrons. All right, pretty simple. We're going to have some practice problems to do, but you will turn these notes in.